Okay, so on to day 3, we're going to learn about the dot product and using the dot product to help us find out more about vectors today. So first, let's refresh our memories on a few definitions. So scalar, remember this is a real number, and vector we defined as directed line segment. So scalar is just a number, vector is a line segment, but it has a direction to it. Okay, before we get into the dot product, let's talk about the law of cosines real quick, because this is going to play into the dot product. Spoiler alert, sorry about that. So if I have some vector u and some vector v, and I want to find the vector u minus v, well, if I draw this picture, so let's say this is vector v, this is vector u, then vector u minus v, would be this. And I could say this is some angle alpha. And so now, from the law of cosines, I know that the magnitude of u minus v squared equals the magnitude of u squared plus the magnitude of v squared minus 2 times the magnitude of u times the magnitude of v times the cosine of alpha. So that's my law of cosines. So I want you to pause the video and simplify this if you can. I'll give you a hint. This portion here you're not going to touch, but the magnitude of u minus v squared, the magnitude of u squared, and the magnitude of v squared, you want to simplify those and combine like terms if possible. If you're not sure what I'm talking about, then just don't pause it and look and see what I do. But try it on your own first. Okay, so what I wanted you to simplify it to, because I'm sure you could read my mind, was x1, x2 plus y1, y2 equals the magnitude of u times the magnitude of v times the cosine of alpha. If you didn't get that, or if you're not sure what I'm talking about, let's look at how I got that. So first we take our equation here, which was from the law of cosines, and the magnitude of u minus v squared is going to be x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Remember, normally magnitude would have a square root over it, but since it's squared, that's gone. The magnitude of u squared is going to be x1 squared plus y1 squared. The magnitude of v squared is x2 squared plus y2 squared, and then we still have the minus 2 magnitude u magnitude v cosine alpha. Multiply out x1 minus x2 quantity squared, and we get x1 squared minus 2x1 x2 plus x2 squared. Multiply out y1 minus y2 quantity squared, we get y1 squared minus 2y1 y2 plus y2 squared. And then the x1 squared, the y1 squared, the x2 squared, the y2 squared, and the 2 magnitude u magnitude v cosine alpha stay the same. Now a few things cancel. So on the left side and the right side I have a positive x1 squared, that goes away. On the left side and the right side I have a positive x2 squared, that goes away. On the left side and the right side I have a positive y1 squared, that goes away. And on the left side and the right side I have a positive y2 squared, that goes away. So now on the left hand side of the equation we have negative 2 x1 x2 minus 2 y1 y2 equals negative 2 magnitude u magnitude v cosine alpha. Now we can divide everything by a negative 2, and that's how we get x1 x2 plus y1 y2 equals magnitude of u times the magnitude of v times the cosine of alpha. So we're going to leave it there, hold on to that thought. Now we're going to look at the dot product. And what do you know? If we have some vector v, which is x1i plus y1j, and some vector w, which is x2i plus y2j, the dot product is v dot w equals x1 times x2 plus y1 times y2. So notice that this symbol here, that is not multiplication, that is telling us the dot product of two vectors. And so what it is, the dot product of two vectors is the sum of the products of their horizontal and vertical components. What does that mean? It is going to be a scalar. So whenever you're doing the dot product, the result is a number. So I want you to find the dot product v.w, w.v, and w.w, given that v is 5i minus 2j and w is negative 3i plus 4j. Also, going back here real quick, sorry, didn't even connect it to what we did with the law of cosines. Notice that our result here, this part, that's the dot product. So the magnitude of u times the magnitude of v times the cosine of alpha is also the dot product. Alright, so now I want you to find these dot products, pause the video, find them, unpause when you're ready to check your work. Okay, so hopefully you got v.w is 5 times negative 3 plus negative 2 times 4, which is negative 23. And w.v is going to be the same thing, negative 3 times 5 plus 4 times negative 2, which is also negative 23. And w.w is negative 3 times negative 3 plus 4 times 4, which is 25. So this leads us to some properties of dot products. So if u, v, and w are all vectors and c is a scalar, then u.v equals v.u. And we saw that here with v.w and w.v equaling the same thing. v plus w is u.v plus u.w. 0.v is going to be 0, which should make sense. And v.v is the magnitude of v squared, which should also make sense if we look back here, w.w. This is what we do to find the magnitude, but normally we take the square root. And c times u.v is c times u.v, or u dot c times v. So if we want to find the magnitude of a vector using the dot product, well, if I call this vector u, and then I know u squared is u dot u, so then the magnitude of u is the square root of u dot u, which in this case would be the square root of 2 times 2 plus 5 times 5, or the square root of 29. So we're using the dot product to find the magnitude. It's the same calculation, it's just recognizing that it can be thought of as the dot product as well. Alright, so now think back to what we did at the very beginning, or our second example I should say, first example with the law of cosines, where we came up with this x1, x2 plus y1, y2 equals the magnitude of u, magnitude of v cosine alpha. Well, we can use this to help us find the angle between two vectors. So an alternative form of the dot product is what we wrote using the law of cosines, but here we can just write the left-hand side of the equation as the dot product. So if v and w are two non-zero vectors and theta is the smallest non-negative angle between them, then v dot w is the magnitude of v times the magnitude of w times the cosine of theta. Therefore, we also know if v and w are two non-zero vectors and theta is the smallest non-negative angle between them, v and w, then cosine of theta is v dot w over the magnitude of v times the magnitude of w, and we can find theta by doing the cosine inverse. So I want you to find the angle theta between v and w. Pause the video, unpause when you're ready to check your work. Okay, so we can use the equation from the previous slide, and we know theta is the cosine inverse of v dot w over the magnitude of v times the magnitude of w. So v dot w is 2 times 3 plus negative 4 times 2. The magnitude of v is the square root of 2 squared plus negative 4 squared. The magnitude of w is the square root of 3 squared plus 2 squared. The dot product comes out to be negative 2. When you combine the square roots, you get the square root of 260. So now I type this into my calculator, and I got theta is approximately 97.125 degrees. Okay, not too bad. Dot product of two vectors is the sum of the products of their horizontal and vertical components. So you need to recognize that. You need to know that the dot product is a scalar, so it should be a number. And then we can also use this equation to help us find the angle between two vectors. Cosine of theta is v dot w over the magnitude of v times the magnitude of w. Something to think about, because this is going to come up, I believe, tomorrow night, is this can also tell us if two vectors are perpendicular or if they are parallel. So think about what the dot product, if we know the dot product, how it can help us find that information. That's it for this video.